Having said that, let's talk about the first board, and here we are. And I want your complete attention for the 10 minutes, next 10 minutes at least, so that you get this board to its core. The idea is simple here. The drawing is simple. Topology is simple. We have multiple autonomous systems here. As you can see, we have four. We have AS100, AS200, AS300, and AS400. Very simple. All the ASs are connected using these white links. You can see them here, here, right? And on R1, I have one loopback, which is 1.1.1.0 right here. This is the network which I want to see how it is going to propagate if I run BGP across all these AS numbers. This is the whole soul agenda of this first board. What is going to change in this route, right? So if I talk about, then between R1 and R2, I have enabled a routing protocol whose name is BGP. Okay, so that is fine. We do not know that how to enable BGP, what are the configuration command, that is fine. But when I say that R1 and R2 are running BGP, the meaning is simple. Now they can exchange route using BGP, because the most important function of a routing protocol is to make sure that your neighbor is getting the routes, or the neighbor can calculate the routes. It is as simple as that, right? So R1 has 1.1.1.0/24, and it is going to advertise it towards R2 over BGP neighborship. What this neighborship is, how we are going to bring it up, that is what we are going to cover, right? In next 10 or 12 sessions. But for now, I want to show something else. So just try to understand, if I have run BGP, then it means that R1 and R2 can talk BGP. Now, if I talk about R3 and R4, we are again running BGP here. If I talk about uh, Balaji, please be on Balaji, please be on mute. Mr. Balakrishna, thank you so much. So if you see here, we are, if I talk about R5 and R6, we are also running BGP here, no problems. If I talk about inside an autonomous system, we are also running BGP, but as you know, if I am inside the autonomous system, the BGP is known as IBGP. If you do not know, then this is the time. If we are running BGP between two different autonomous systems, then we call it as an EBGP. Otherwise, it's an IBGP. It's as simple as that. But what is this EBGP and IBGP? Believe me, guys, we are going pretty detailed about them. I'm not finishing this topic right here that IBGP is this much and EBGP is this much. No, the whole sole idea is to see how route propagates in BGP. Okay. If I talk about R4 and R5, you can immediately understand that here IBGP is running because R4 and R5 is part of the same autonomous system, right? And if we talk about R5 and R6, it is EBGP once again, and R6 and R7, it is going to be IBGP. No problems, right? Now let's see what is going to happen if I advertise 1.1.1.0 in towards R2 from here to here. I'm showcasing this with a green arrow. So what we are going to do, we are going to write the routing table of R2 now. So I am going to write route table for router number R2. What we are going to see here is that, of course, there's going to be a BGP route, and that is why I represented B here, right? And then 1.1.1.0/24 is learned via R1. This is very, very simple. You know about it and you do not see any interface. That is perfectly fine, right? Now, this route is going to be advertised from R2 towards R3 over the IBGP neighborship. Now, what I'm going to do is I am going to write down the routing table of R3. And interestingly, the neighborship between R2 and R3 is IBGP. Let's have a look. What is going to be the change in the route? We are going to see BGP route, no problems with respect to that. Whether it's IBGP or EBGP, it's a BGP route. Okay. We are going to write here 1.1.1.0/24 via, interesting, and we discussed about it. BGPs wants to reach you to the next autonomous system number. How do you reach that? It doesn't care about it. If you can reach, then maybe you can reach to 1.1.1.0, otherwise not. So BGP is going to say, although R3 is learning this route from R2, this guy is learning this route from R2, but still BGP is going to say that if you want to reach to 1.1.1.0, Mr. R3, you have to reach it via R1. And this is where everything gets changed, right? In normal IGP, right? If you have three routers, R1, R2, and R3, if R1 is sending a route to R2, R2 is sending a route to R3, then of course R3, in R3's route table, suppose the route is x.x.x.0/24. In R3's routing table, to reach x.x.x.0, it is showing via R2 because at the first place the route was learned via R2. It is not going to say that the route is learned via R1. This is the difference, right? Because IGP's approach, IGP's whole sole agenda is to send this route from here to here, right? And basically the whole sole agenda of R2 is to send the traffic first to its neighbor, and then neighbor is going to be forwarding wherever it is. It is as simple as that, right? So the neighbor address is going to be your immediate neighbor, which is connected to you. But right now, right here, if we talk about R3, the neighbor address is not the immediate neighbor, which is R2. The neighbor address is R1 because BGP wants that if you want to reach 1.1.1.0/24, you can reach via R1 because R1 is the gateway towards AS100. Maybe in AS100 you have multiple routers, maybe thousands of routers in a single AS if it is a service provider. How you are going to reach all those routes? You are going to reach all those routes using this R1, right? So BGP say, just go and reach to R1. If R3 does not know how to get into R1, then there is no point, right? Then it cannot reach 1.1.1.0/24, right? And BGP also says you figure out that how you are going to manage to R1. If you can manage, maybe it doesn't care. Maybe in R3 you have a route, right? To reach R1, you can go via R2. You can have this static route installed, which shouldn't be a problem, right? Or maybe you are running any other protocol, maybe OSPF to reach to this R1, but BGP want that you should reach, right? But the whole sole point is this change in the first route, you can see it is via R1. In the second route at R3 also it is saying via R1. It is interesting. Now let's move this route towards R4. Now you are sending this route from R3 to R4. It is as simple as that right here. Okay, let's write down the route table of R4 now. Route table of R4. It is going to say BGP route. 1.1.1.0/24 via. Interestingly, here it is going to say it is reachable via R3. And the reason is, and the reason is, it is actually learning the route now from AS200, right? And that is the next autonomous system from which this route was received. And hence, if you want to reach AS200, you need to go to first to router R3's this interface. And that is why the next hop is going to be this interface. Although I am writing R3, but if I am writing R3, you should understand that the IP address which is configured on this interface. It is as simple as that, right? And now BGP is doing one interesting thing here. What interesting thing? It records the AS through which this route is passing, right? So when this route was learned on R2, right? Along with this route, BGP write down from where it got this route. And it got this route from AS 100. If I talk about on router R2 right here, and BGP mark these AS number that it got it the route from AS 200. But of course, if you talk about inside AS and AS 200, if we are talking about router R3, we are still in AS 200 and the route was learned from 100. You must be thinking why I haven't included 200, because I'm R3, I am also part of 200. R2 was also part of 200. If this route goes out from AS 200, then that guy who is receiving the route is going to get AS 200 more along with this AS 100. So it is very interesting to see what is going to be this path, what is going to be the AS number when this route 3 is going to reach to router 4 right here, right? Of course, whatever router 3 knows that basically this route is from AS 100, and now router 4 knows that of course that I get this route from AS 200, so I will be writing AS 200 here. Interesting, right? What is the meaning of this AS 100 and AS 200? R4 can easily figure out that basically 1.1.1.0 is actually 1.1.1.0 is actually originated in 100, then it traversed to 200, and then it reached me. It is as simple as that. So generally, through this, R4 come to know about that path which is followed by this route. It is as simple as that. So just pay close attention. Along with the route, every router in BGP is tracking this value, right? Which value? Your AS numbers. It is as simple as that, right? Let's talk about what is going to happen at R5 from when R4 advertised this to R5. We are talking about the same autonomous number. We are talking about the IBGP here, and you can understand what is going to there. So I am writing down the route table for R5, and it is going to be BGP 1.1.1.0/24 via, we are at R5, we are writing here via, absolutely you can understand it is still R3. And the reason is the goal is of the BGP is to send your packet to the next immediate autonomous system, right? Not the next hop router. If you are inside the IBGP, you're talking about the next hop router which is inside your autonomous system. The goal is to send it to next autonomous system number from wherever you are getting this packet. And if you write down here the AS numbers, it is still, you are still in AS 300, AS 100 is here, AS 200 is here, and anybody who is getting this route from 300, then that guy is going to add this 300 here. It is very, very interesting, right? Now, let's try to understand what is going to happen if we advertise this route from R5 to R6 right here, right? If the question is coming to your mind, please raise your hand and I'll make sure that I will stop right after this board for your questions, right? Let's talk about from R5 to R6. We are at the R6 now, and let's write down the routing table of R6, right? We are talking about routing table of R6. Again, route is 1.1.1.0/24. It was learned using BGP, right? And the next hop is going to be this time via R5 because this is an eBGP neighborship. You are actually learning this route from different autonomous system, and if that is the case, then that is why the next hop is going to be R5, which is the gateway into the AS200. It is as simple as that. And if you want to see the the path of administrative systems, right, or administrative system paths, then of course the route was generated in 100. It traversed through 200. Sorry for this. It traversed through 200 and then basically it also traversed 300. Interesting. R6 has slightly bigger vision. And guys, we are talking about autonomous systems. This guy can have multiple routers. AS300 can have multiple routers in it. But we don't care. BGP don't care. BGP see these groups of multiple router as a one entity, and it is representing this entity into this, right? And what is this, guys? This is showcasing you the actual path taken by the route, right? So if you are in R6, you know that the route was originated in AS100, okay? It traveled through 200, then it passes through 300, and then it reaches me. It is as simple as that. And if we talk about, let's complete for the discussion, we are having router uh, R7, and let's write down the path. Let's write down the BGP route 1.1.1.0/24 via, it's again going to be R5 because we are talking about iBGP. BGP's goal is to send the packet to the next immediate autonomous system first, and then next, and then next. It is as simple as that, right? So your autonomous system path is going to be same 300, 200, 100. It is simple, right? Simple and interesting. So this is how BGP route propagate. Along with the route, BGP maintains a list of number, which is actually the AS path, which tells BGP router that from how many AS number this route is passed, right? So it means that BGP knows something about the topology, right? But in terms of AS numbers. So if I talk about route, then we have this route, and along with this route, BGP has some properties of that route, some interesting things about that route. So BGP has write this information, and BGP call them as attributes. So AS path is the attribute of BGP route. If I am on router 7 and if I see this route, then I definitely can see this property of this route. What are the various properties? What are the various values attached with this route? And of course, the first value is going to be 1.1.1.0, which is the network number, how it is going to be reachable, the next hop, right? And along with that, you are going to see some of the attributes also. And the number one attribute here, which I am showcasing you, is your AS path, because these three AS numbers are representing the path taken by the route from its origination to from its origination to you, or when it reached to you. It is as simple as that, right? So you must be thinking that, are we using this for something, or we are just having this information along the route. So believe me, guys, the designers, the developers do not do anything unless it is going to be used somewhere. Otherwise, what is the purpose of getting these values on each and every route? There is going to be specific purpose of it. But I want to showcase you that BGP has a route, and when it propagates, what happens. And along with this route, BGP stores some more information about this route, which was not there in the normal routing protocols, right? No routing protocol was able to mention all these things because we were running the IGP inside the autonomous system number, and here we are talking about different autonomous system numbers. So guys, if there any question on this board, please raise your hand. Otherwise, I am moving to next board.